forgot I need to record it. So one of the properties of light is that it reflects off surfaces. So everyday experience shows that light is reflected off some surfaces. Among other things, this reflection allows us to see images in mirrors. We see the images in mirrors as apparently coming from behind the mirror because our eyes interpret it in this manner. We are going to talk a little bit more about eyes because I think that eyes are really cool things, but you can also trick them very, very easily. So our eyes always assume that light travels in a straight line. Okay, so although we know that light bounces off the mirror and comes back to us, our eyes assume that light has just come from straight behind the mirror. So that's why it looks like we are behind the mirror, because our eyes have been fooled, basically. And we'll do more about that later on in this booklet. When we see ourselves reflected in the mirror and raise our left arm, the image apparently raises its right arm. Okay. So what you guys are going to do is you're going to do an experiment with reflection to start off with. Okay. So we're going to use ray boxes. I'm going to show you how to do these in a second, but I want you to just label some things on this diagram so you know what I'm talking about when I refer to certain things. Okay. So this here, if you see something drawn like this is the symbol for a mirror. So the line with like the line hash lines coming from it. So that is a mirror. Because obviously it's quite difficult to draw a mirror. Because how do you draw a mirror? We've got three things drawn in there already. We've got the angle of incidence, which is between the incident ray. So this is the ray that you send in towards the mirror. And this normal here. So the normal is always at 90 degrees to the surface that you are shining light onto. So that's always at 90 degrees. That's a right angle. We've got an incident ray, which is the ray that you shine in. And we've got that angle of incidence, which is always between the normal and the incident ray. What I need you to draw in now is a ray being reflected. And that is, funnily enough, called the reflected ray. And we've got an angle here between the normal and the reflected ray called the angle of, can anyone guess? Yep, reflection. Okay, so all those different names for different things are important, and you will be using them quite often. Okay, you will be adding to your vocabulary as well, but you have just learned a few things. So incident ray, the light going in. Reflected ray, the light being reflected. Angle of incidence, which is between the normal and the incident ray. And angle of reflection, which is between the normal and the reflected ray. Okay. So once you've drawn that, I'm going to show you how to use the equipment that is on your desk. So you should see at the side of your desk, you've got like a little toolkit. That's what you're going to be using for the next few lessons. Don't need it just yet, I'm just going to show you that to you. So inside your toolkit, there are a variety of different things. So you're going to be looking for the mirror, okay, and a ray box. So this, right in the middle of your toolkit, there is a ray box with that, okay, and you need to plug that into your power supply, which should be next to your toolkit. It doesn't really matter which way you plug it in. You plug it in yellow to yellow or red to black. Doesn't matter. So you've got a ray box. You also need to find a little black card that's in that kit as well. And you're looking for the little black card that has just one slit on it. You're going to be using the one slit first of all. Okay. So you pop that into your ray box. You see the ray box has got sort of like some wings here. You close those and it goes to the opposite side of the wings. You just slot it in there. So when I turn it on, we see a light coming out there, just a ray of light. Okay. Lights will be going off. I'm afraid those buttons are you've got different angles. So this is 10 degrees, that angle of incidence, so between the normal and the incident ray, that one is 10 degrees. That's 20 degrees to the normal, that's 30 degrees to the normal, 40 degrees, etc. So if we go back to our booklet, we can see that we want to measure the angle of reflection at different angles of incidences. So what you're going to do is you're going to shine your light, and you need to make sure that it shines into where the normal hits the mirror, like that. So that's me shining it in at 10 degrees. What I do then is I get my pencil, and I just lightly draw where the reflected ray is. So you do like a dotted line, you probably use a ruler. So you can see there, just about. Obviously, it wouldn't be as rough as that. That's my reflected ray for 10 degrees incidence ray. So what I want to do is I want to measure that angle between the normal and the reflected ray and write it into that table there. Then you're going to change your angle of incidence. So you're going to go to 20 degrees. So you always point it towards where the normal, and you draw in that, and then measure the angle again. Always from the normal to the ray. Okay. Then change it up again. So move to 30 degrees. Measure that angle from the normal to the ray. So always draw them in first of all. It's a lot easier to measure. Yes.
When you're finding your angle, is it from the normal?
Yes. From the normal. Yeah. Always from the normal. There's a protractor in the toolkit as well. If you don't have your own protractor. Okay. So it always from the normal. So this one's 30 degrees, for example. If I'm shining it in at 30 degrees, I draw that in there, and then that would be my angle. Yeah? Any questions? Right, okay. 5 minutes to set up. We've got one quick test, so try and keep social distancing. And then I will turn the lights out. Sorry? No. No.